Now we bring in the Big Daddy. There's four main rules here. Okay, four basic main rules. That's the power, the product, the quotient, and the chain rule. And the chain rule, that's the biggest, that's the most important one. That's the one that we actually use the most. Instead of just having simple little formulas, sometimes life is just messy. So this is what happens when you have one function inside of another function. There's 5 examples of chain rules. Like I said, it's one function inside of another. So right here for purple, we've got a square root function. Oh, and we also have a parabola or a quadratic function. Over here, we've got a sine function, and inside of that sine function is a linear. Right here, we have what's known as a reciprocal function. Think of this function as 1 over something. Or in this case, it's 16 over something. What is that something? Well, it turns out it is a cubic. This is a quartic function, something to the 4th power. But what are we taking to the 4th power? Tangent is the inside function. So, and even over here, we have a quotient rule. We have a rational function here, but it's being taken to the 21st power. Whenever you have a mixture of these two, what we're going to do is we're going to break it up into the inside function and the outside function, and put them all together, and we're going to solve these functions. So let's keep an eye on these and make sure we don't forget them and move to the next step. What I'd like to see here is that you rewrite this and say, well, I've got the outer function. I've got the square root of something. What is that something? I don't know. We'll just call it u. U got something. Okay? What is that u value? Well, over here we've got a square root function. We've got something to the 1/2 power. What is that something? What is that inside function? 4x squared plus 3. If you can break this down into the inner and the outer functions, this is going to be a piece of cake. Now, take the derivative of each of these individually, like this. But of note, the way you write this out, it's really important that you get the left side of this equation correct. Normally, when we're finding the derivative of something, it's dy over dx. Why? Because it's the slope. It's the change in y over the change in x. Notice we don't have any x's up here. We have a y, but no x. What we're looking for here is the derivative, the slope of this function, would be the change in the y value over the change in whatever that letter is. I think it's u. And for this one, now I have an x value but no y value. I'm looking at the change in the vertical over the change in the horizontal. It's du over dx. So we're taking the derivative of those two separately for this purple function that's back here, right about there. And now, there's one very simple step. We would like to know the slope, dy over dx. What we happen to know is dy over du, and we happen to know what du over dx is. I wonder what would happen if we multiply those two things together. What parts of that might, just coincidentally, divide out? I hope you guessed it. Won't those du's just kind of simplify out? Du divided by du is 1. So I hope you don't mind that I rewrote this. I know it's u to the negative 1/2. I wrote it this way. That's u to the negative 1/2 times du dx, which is 8x. And when I multiply those together, we will get this mess right here. There's only one problem. Look at this original equation. There were no u's there. I wonder what we can do with that. Maybe we should rewrite this final answer in terms of the same letters we had before. You told me up here that u is equal to 4x squared plus 3. Well, there it is. U is equal to 4x squared plus 3. We back substitute on the final step. So, quick synopsis here. Break this up. Step 1, break this up into the inside function and the outside function. Step 2, take their derivatives separately. Take the derivative of the outside and the inside. Step 3,